Our next speaker is Calista Redmond. She's the CEO of RISC-V International. This is one of my favorite projects in the Linux Foundation ecosystem. Calista's background includes building and leading strategic business models within IBM's Systems Group through open source initiatives including Open Power, Open Daylight, and the Open Mainframe project. Today she will discuss the rapid growth of RISC-V as the inevitable standard architecture driving the best processors and upstream advantages across industries. Please welcome Calista Redmond.
Anyone want to name that song? All right, thank you so much for hanging on till Friday. I know I'm your last keynote of the day, so I am super excited to talk with you a little bit about RISC-V and what we're doing over in standard, RISC-V standard as a open ISA. You know, we're a little bit different. We're hardware, and I know this is mostly a software-oriented crowd, but you know, when you think about the challenges that we face as a society, as a world, we think about coming together. Maybe it's a pandemic. Maybe it's a technology challenge. Maybe it's pushing the boundaries and the frontiers that we all look at in front of us. We do this through collaboration. We do this through transparency. We do this through standardization and open source and continuous improvement. So this is strategic to not just software, but to hardware, and in all the ways that we come together. So I'm going to leave you with 3 thoughts today. First, RISC-V is inevitable. RISC-V is taking over the domains where proprietary architectures have kind of ruled technology for the last many decades. You know, we saw this in software once upon a time where proprietary approaches we're the only approach, we're the only answer. And now Linux kind of shores up computing workloads around the world. Second, RISC-V enables the best processors. This is by design, from both a technical angle as well as a business angle. And RISC-V enabling the best processors is sort of a bold statement, right? We'll get into that. RISC-V is rapidly building the strongest ecosystem. When you bring together collective investment around the world across workloads, you truly unleash the potential to have all workloads running on all architectures. And we've seen this before, so let's dig in. RISC-V is inevitable. We already have more than 10 billion RISC-V cores in market today, and that innovation is at all ends of the compute spectrum, from the lightest weight, lowest power processors to the highest performant processing. We already have this work underway. It is no longer a question of what if, it's a matter of when is it going to reach my workload? When is it going to reach my implementation? And so we see this demand happening from low to ludicrous and across that whole spectrum. So it's not just about the technology. It's never just about the technology. If it was just about the technology, we would call it a hobby. But this is not a hobby, this is real business. In fact, business is booming. We see charts like this pretty much every day. It's that hockey stick. This is the next frontier. This is the part where hardware is cool again. In fact, we see, you know, our market share going, it says here from 1% to 16%. Let's just call it from 0, right? Because it wasn't too many years ago, maybe 5 years ago, where RISC-V didn't even show up on the map. And now we're looking at 16% in the next couple of years. That's pretty profound when you think about the number of investments already in existing architectures and how far we've come from 0 to something this profound. So this is going on across the compute workloads, most notably in those areas where custom processing is in demand. Things like AI, acceleration, and all the really cool things we've been doing in HPC for decades that are now coming to the data center, now coming to enterprise workloads. And this isn't just a hallucination that's going to happen in the future. In fact, it's already happening today with nearly a quarter of design starts already on RISC-V. And by the way, this is a severely out-of-date slide. The source of this is from like 2019. So what is it? You know, this is the same thing that's happened across all of open source. It's that collective investment. It's the shared investment, the shared mission to do something better than we've been doing before, to do something more profound that enables more participation. It's that plug and play mentality. Let my workload run on all architectures. You know, having your, eggs in more than one basket is sort of a business imperative. Running your workloads on more than one architecture, whether that's x86 and ARM and OpenPower and mainframe and all the other great architectures out there, this is an opportunity to run on RISC-V as well. And that promise is being shored up by massive investments from governments, from venture capitalists, from startups to multinationals. Does anybody remember back in about 2001, Linux was just kind of coming out of the garage, right, and into mainstream. And companies were like, oh no, can you trust open source? Can you go there? Well, what if it cannibalizes my own proprietary software business? And in 2001, IBM looked at that opportunity and said, yeah, we've got a big proprietary software business. But here, I'm going to plant $1 billion flag on Linux, and Linux took off, and here we all are today. So about a year ago, Intel went ahead and planted $1 billion flag on RISC-V and said, let's go. We've got our architecture. It's not going to cannibalize our business. Let's do both ends. That makes a lot of business sense. So we moved forward, and many governments started to get on board. In fact, we have RISC-V as a national architecture in several different countries. The Ministry of India, the China Academy of Sciences, DARPA here in the not here in the US, I guess we're in Canada. DARPA and other organizations, in fact, even NASA, my friend that was just on stage here. Even NASA is bringing RISC-V to the moon. The European Space Agency is bringing RISC-V to the moon. The European Union is designating several projects, several grants and bids that we've been a part of that say open hardware in RISC-V is a necessity in this project, right? That's shared investment. All right, let's talk about business opportunity. Automotive, 10% to the market by 2025. Data center and cloud, more than 14% of the market. Remember, this is from a starting point of 0. So our CAGRs are often pretty substantial. But data center and cloud, growing very rapidly, more than 14%. In telecom and communications, do you know that Qualcomm, who has been very good friends with ARM for a long time, got up on stage and said, you know what, we've already shipped 650 million RISC-V cores. Hopefully this message is kind of sinking in a little bit, like, wow, where's my RISC-V strategy? What is my team doing on this? What am I doing on this? Well, how am I taking advantage of this? Because this is where the future is going, and it's already well underway. Consumer and IoT devices, from wearables to the Wi-Fi and Bluetooth connections in your cell phone, there's a really high chance that that's already RISC-V. We're on our way to nearly a third of that market. AI and ML. Well, if you drive up and down Silicon Valley, this is what every other billboard is talking about. How are you accelerating your workloads? Where's your ChatGPT? How are you implementing AI and ML into the critical thinking that your organization does to drive business value, to make strategic decisions, right? So growing rapidly in this space, we have quite a few members who are taking this to the next level. High performance RISC-V processing. We are no longer relegated to one end of the spectrum called embedded. Still very popular in embedded though. High performance computing, I've already mentioned several of the agencies that you see also reflected on this page that are investing in RISC-V because that's where the next frontier is going, whether that's around genomics, oil exploration, national security, finding and discovering cures or vaccines for some of the pressing concerns that we have today. This is all around security as well. All right, let's go to point number 2. Remember, point number 1, RISC-V is inevitable. Point number 2, RISC-V enables the best processors. Why? Well, Most processors start you off with a base package of 1,500 instructions. RISC-V starts you with 47. On that 47, you pick and choose just the extensions that fit for your workload. This enables you to customize your approach through the hardware end to get the performance or whatever the other variables are that you're designing to. Pick your challenge. Is it power consumption? Is it price? Is it performance? This isn't about speeds and fees anymore. It's about meeting the demand and then going for scale. So that design flexibility and freedom is something that's, I won't say impossible. Let's go with expensive to do on any other architecture. Expensive because you're going to need millions of dollars, quite a few lawyers to negotiate that contract, and a massive team of engineers rather than the shared collective, thousands of engineers that we have working on RISC-V. That massive community. Today we have more than 11,000 engineers working on RISC-V around the world, around the clock. Around 70 different technical work groups to provide a base set of building blocks to help you compose a solution that really speaks to your challenge. This, by the way, I've mentioned that we're a global standard. We're not open source, we're an open standard. And this is something the industry has seen before. When you think back, there used to be networking in a data center, always driven by a proprietary approach. And that then dictated what systems and servers and interconnects and switches you put into your data center as well. That's a pretty sweet deal. You get it all from one provider. Plug and play, very difficult. Along came Ethernet, a global standard. Plug and play, pick and choose, do it your way. Same thing with RISC-V. RISC-V is coming in as a global standard. And that's where we expect to see the same adoption level and rate of growth and implementations as you've seen on other global standards. And that is indeed starting to take off. So highest performance. We see a lot of benchmarks coming out that meet those critical demands of the workloads that you're looking for. So there's a bunch of links here. There's a lot more links that we can provide. All right, let's talk about ecosystem. So, you don't just want hot metal. You want to actually run productive workloads on top of that. And so that's where that great ecosystem is coming in. So global standards, open standards, drive for that, ability to port, optimize, and build to either the specifics of that underlying architecture or, at minimum, to be portable across architectures. So just as Red Hat and SUSE and others run on multiple architectures, this is an opportunity to run on RISC-V as well. So reminder on your things to do list, you don't have to do it today, but maybe Monday morning, what are we doing on RISC-V? So think about the various things that you need to run. You need tool chains, you need libraries, and these are the things that we're pulling together as one unified community. Now, folks always bring up fragmentation, right? Oh, what if it fragments? What if somebody takes it off into the weeds? Nobody wants to do that. There are massive forces working against that. No single company or country can really afford to run their entire own ecosystem. So the forces working against fragmentation are pretty significant. And that's what we're seeing in our community as well. But what are some of the benefits of running on RISC-V? Well, there are three key benefits that I'd point to. Domain-specific extensions. So we actually have reserved encoding space that you can, roll your own, build your own. It's similar to other open source initiatives where you have your base building blocks, then you bring your differentiation, your secret sauce on top of and around that, go to market and be wildly successful. Platform standardization. This is another area where we have a force working against fragmentation. So we have things like profiles and architecture compatibility tests that you can run and get adherence to. In fact, Alibaba is one of our key stakeholders who has really taken a lot of steps to work with us on that compatibility. And then finally, contributor culture. This is something that's near and dear to all of us in the open source world, right? building on that contributor culture. Roll up your sleeves, hands on codes, let's get it done together, and let's share that. Because you want everyone to take the same approach that you're taking to optimize your workloads. So we're building an ecosystem. We're gaining a lot of adoption across various workloads at all parts of the stack, whether those are specific to industry or horizontal across multiple industries and domains. Folks that really love us for the security that we bring. We have a lot of safety as well as security critical applications and things that are running today across various things. And we are growing very rapidly. We grew about 30% last year, and we're on a pretty strong rate and pace to do it again this year. So we have more than 3,400 members in 70 different countries, pretty evenly distributed around North America, Europe, and APAC. And that continues to grow and build across all different types of stakeholders. So I encourage you, I implore you, put on your to-do list for Monday morning. What am I doing on RISC-V? Who in my team is going to help us on our RISC-V journey, right? Think about the passion you feel in open source as an individual, as a team, as a company, and how are you building that into your mission? And think about how you can do that together with us in RISC-V, and reach out to us and engage. Thank you so much, and enjoy the rest of your conference.